we are going to do one last example in this section. We're going to find the area between the graph of a function and the x-axis over a closed interval. And in order to do this, we're going to follow 3 steps. First, we're going to find the zeros of the function and use those zeros to subdivide our closed interval into several subintervals. So we're going to have little intervals. And then we will integrate on each of those subintervals. So some of those subintervals may be negative. If they're below the x-axis, that area that we're going to get using our definite integral value is going to be negative. So at that point, we would add the absolute values in order to calculate the total area. So in this example, we're dealing with the function x cubed minus x squared minus 2x on a closed interval from x equals -1 to x equals 2. So my first step here, I'm going to take the function and calculate the zeros. And the zeros are calculated by setting that function equal to 0 and then trying to factor. In this situation, I can factor out a GCF of x, which leaves me with x squared minus x minus 2. The quadratic factor can still factor a little further. We've got x minus 2, x plus 1. So the zeros for my function are going to be at x equals 0, -1, and positive 2. So let's consider the graph. It's always helpful to consider the graph. This is the graph of a cubic function. Rising left to right, it has a positive leading coefficient. So what we're going to see is it goes up, crosses over, and then continues to go up. This is what our graph looks like. And we have our zeros at -1, 0, and 2. And we are interested in finding the area underneath the curve, which is only going to give us, it's going to leave us with these 2 humps, one above and one below. So we're going to calculate this first area from -1 to 0, and then the second area from 0 to 2. We're going to need to divide -1 to 2, that interval, into 2 subintervals. So I'm going to integrate my function over each subinterval. So step 2. If I were to set this up, my area would be equal to the integral from -1 to 0 of my function with respect to x plus absolute value of my integral from 0 to 2 of f of x dx. All right, so I have to use that absolute value because I know that the area between the curve and the x-axis, when it's below, that's going to give me a negative value. And I don't need to write absolute value for the first piece because I know that's going to give me positive. So my function is x cubed minus x squared minus 2x. We have 2 integrations to do and evaluate. So, A, we have the integral from -1 to 0 of x cubed minus x squared minus 2x dx plus the absolute value of the integral from 0 to positive 2 of x cubed minus x squared minus 2x dx. All right, so the integration for both of these is pretty easy. We'll use our power rule. For my first piece, I have x to the 4th over 4 minus x cubed over 3, and that would be minus 2x squared over 2, which is just going to simplify to x squared. So we're going to need to evaluate that from 0 to -1. plus we'll do the same thing and we'll get the same integral for the second piece. Again, we'll get x to the 4th over 4 minus x cubed over 3 minus x squared, and evaluate that from 2 to 0. So let's see what we get here. First, I'll plug in 0. 0 to the 4th over 4 minus 0 cubed over 3 minus 0 squared. That gives me a value of 0. Then I have minus. We'll plug in negative 1. Negative 1 to the 4th is positive 1 over 4. Minus negative 1 cubed is negative 1, but minus a negative 1, we got plus 1/3, and then that would be plus 1. So this first value here, when I add these two together, I end up with 5/12. So I have 5/12 for my first portion of integration. So let me do my second piece. First, I'll plug in 2. Plugging in 2 gives me 2 to the 4th over 4. That is 16 over 4, or just 4. 2 cubed is 8, so minus 8/3. Minus 2 squared is 4. And then we'll plug our last value in, 0. So minus, and we already did that in the first piece, we'll get 0 here. So the two 4's cancel each other out, and we don't need the minus 0. I end up with the absolute value. We'll say I have plus the absolute value of negative 8/3. So I got a negative value for my definite integral there because we recognize that that space was below the x-axis. So if I am to add together 5/12 plus a positive 8/3, I get the value of my area under the curve, which is 37 over 12. So that represents the area, not the definite integral. The integral is different than this area problem. And so I've pulled in a nice picture from our text just to help you see. We have our 5/12, and then our negative 8/3 is coming from this region. So we had to turn that to a positive 8/3 value to add them together and get that the total area of the curve, x cubed minus x squared minus 2x, along the interval from -1 to 2, that total area is 37/12.